Hi everyone. Today I'll be talking about the battery management system, also called BMS. We often call it the unseen hero of large scale batteries because while most of the people never notice it, the BMS plays a crucial role in making renewable energy storage safe and reliable. By the end of this presentation, you will understand why no large energy storage systems can run without it. Our future is renewable energy. Solar and wind are leading the way, but the problem is they are not constant. The sun sets every evening and the wind doesn't blow all the time. This creates instability in our power grid. Sometimes we have extra electricity, sometimes not enough. You may have noticed flickering lights or sudden blackouts. That's the grid struggling to balance supply and demand. So, how do we fix this? By storing excess energy in large batteries and using it when we need it the most. Large batteries act like giant power banks for entire cities. They store energy during the day or during high winds and release it at night or when the demand is high. This sounds simple, but in reality, storing energy at such a massive scale is risky. If even a small problem happens inside the battery pack, the result could be dangerous and costly. That's why we need something to act as the brain of the battery system, and that is the battery management system, also called BMS. Let's imagine a battery system without a BMS. A single battery cell could overheat or get damaged. When this happens, it can enter what's called thermal runaway. This is when the cell keeps heating uncontrollably. The heat then spreads to the next cell and the next one like a chain reaction. Before long, the entire battery pack may catch fire or even explode. This isn't science fiction. This has happened in real world energy storage sites. The damage runs into millions of dollars. Firefighters find it very hard to control, and communities around such sites are put at risk. Now, let's see a small animated video which demonstrates how this thermal runaway occurs. Battery fires don't just destroy equipment, they damage the public's trust in renewable energy technology. Imagine a city that depends on clean energy and then one day the storage site burns down. People will start doubting the safety of renewable systems. That's why ignoring BMS is not an option. It protects not just the battery but also the people, money, and the future of renewable energy itself. So, what does a BMS actually do? Its job can be explained in four main pillars. Monitoring. It constantly checks the battery's health, temperature, voltage, and current. Protection. If something abnormal is detected, it immediately takes action to prevent danger. State elimination. It calculates how much energy is left and how healthy the battery is. Cell balancing. It ensures all cells are equally charged and discharged so the battery lasts longer. Let's go deeper into each of this. First is monitoring. Sensors are placed on every cell to measure voltage, current, and temperature. This data is continuously collected and analyzed by the BMS microcontroller. If a cell is overheating or its voltage drops too low, the BMS immediately knows. Next is protection. Based on this monitoring, the BMS can take action. For example, if the current is too high during charging, it can open relays and stop charging. If the battery is overheating, it can switch on fans or liquid cooling. This is like having a guardian angel that reacts instantly when danger is near. Then we have state elimination. This is where the BMS becomes smart. It calculates two important values: state of charge, which is like the fuel gauge telling us how much energy is left. Next is the state of health. which is like health score telling us how much the battery has aged compared to when it was new. It helps operators plan maintenance and avoid sudden failures. Finally, cell balancing. A battery pack is only as strong as its weakest cell. Without balancing, one weak cell can bring down the whole pack. The BMS ensures all cells are kept at the same voltage. It either discharges stronger cells a little or transfers charge to weaker ones. This balancing keeps the battery efficient and extends its lifespan. Now, let's see how a BMS is actually built and how it works. A BMS is made up of several components, sensors. These are like the eyes and ears measuring voltage, temperature, and current. Microcontroller. This is the brain. It collects all the data and makes decisions. Communication module. It allows the BMS to talk to operators, inverters, or control centers, usually through CAN bus or wireless. Balancing circuits. These ensure energy is evenly shared between cells, though either passive or active balancing. Switches and relays. These are like muzzles. When danger is detected, they disconnect parts of the system or shut it down to keep it safe. Here's how it works step by step. The sensors collect data from each cell. The microcontroller checks the data against safe limits. If everything is fine, charging or discharging continues. If something goes wrong, relays or cooling systems are activated. Meanwhile, balancing circuits keep the cells equal and the communication module shares updates with operators. So, in short, the BMS is like the nervous system of the battery. Sensors are the senses, the microcontroller is the brain, switches are the muscles, and the communication is the voice. The modern BMS systems are becoming even smarter. With AI powered predictive maintenance, they can actually predict failures before they happen. By analyzing past data, they know which cell is likely to degrade or and when, so operators can replace it before it causes problems. With cloud connectivity, the BMS can send live data to remote control centers. This means one operator sitting in a control room can monitor and manage hundreds of batteries across the country. It also allows over the air updates so the BMS software can be improved without even touching the hardware. We already see BMS in action across many industries. In utility scale storage facilities, which are like giant battery farms that stabilize national grids and store renewable energy. In EV charging hubs, where hundreds of cars are charging at the same time, the BMS ensures power is delivered safely without overloading the system. And in grid stabilization, where batteries prevent blackouts and keep electricity flowing smoothly even when demand suddenly spikes. To conclude, the BMS is silent protector of our renewable energy future. Without it, large-scale batteries would be too dangerous to rely on. With it, we can ensure safety, reliability, and efficiency. So the next time you think about solar panels, wind turbines, or electric cars, remember behind the scenes, it's the battery management system that keeps everything running smoothly. It truly is the unseen hero powering our clean and sustainable future.